This lecture is in continuation to the working of a single phase capacitor commutated current source inverter with resistive load. So in this lecture we are going to explain about the various waveforms obtained across each of the components. Now here you can see that the first set is nothing but the gate triggering of the thyristors G1 and G2, then gate triggering of the thyristors IG3 and IG4. So from 0 to T by 2, T1 and T2 are fired, and from T by 2 to T, T3 and T4 are fired, which you can observe it from here. Now, this is the waveform of IAC when you are firing the thyristors T1 and T2. Now, the next thing is we are going to plot V0, I0 and VC. So from here you can just observe that this is the load, and VC is nothing but the voltage which is across the load. So therefore I can say that the voltage across the load V0 is nothing but the capacitor voltage VC. Now before firing the thyristor T1 and T2, the capacitor was assumed to have a charge of minus V1. So therefore minus V1, the capacitor voltage VC, I can plot at 0, I can plot it as minus V1. And after that, the capacitor starts to charge in the opposite direction. That is, from 0 to the period T by 2, the capacitor starts charging with the left hand plate positive. So therefore, by the time it reaches T by 2, the voltage will be plus V1. That is, the capacitor voltage is changing from minus V1 to plus V1. That is one thing. And this capacitor voltage V0 is same as VC is same as V0. So therefore we have plotted both on the same axis. Now the next thing is I0. So I0 is nothing but the current through the resistance, which is nothing but V0 divided by R. And that V0 divided by R is nothing but at the time t equal to 0, V0 was minus V1. So it is minus V1 by R. I will name it as minus I1. And while it reaches t by 2, the voltage has reached plus V1, and therefore I can say now current I0 is nothing but V1 by R, which is I1. And therefore the current will also following the same way in which the capacitor or the output voltage is going. So that is nothing but this waveform. So first it was minus I1 and then it was plus I1. Next is we need to plot the capacitor current IC. For that you consider the node A, this one. So therefore here I can write I is the total current which is coming inside, which is splitting into 2, that is I0 plus IC, or I can write IC as I minus I0. At the instant of t equal to 0 plus, that is at this instant, your I0 is minus I1. I0 is minus I1. Therefore, substituting it in this equation, I can write it as IC is equal to I plus I1. That is minus of minus I1. That is plotted over here. After that, what is going to happen? The capacitor is going to charge. That is from minus V1 to plus V1. So by the time the capacitor is fully charged, we can say that the current starts reducing. Now we are looking at the instant of t by 2, just before t by 2. So I will write it as t equal to t by 2 minus, just the instant before t by 2. So that time what happens? Your current is approaching, I0 is approaching plus I1. So I can say that I0 is I1. So therefore, substituting in this equation, I can write IC is equal to I minus I1. So that is being plotted over here. Now the same thing will be repeating for the rest of the things. Now again, you need to plot the voltage V in. So this is V in. This terminal is not going to change. But the thing is that the current will be flowing like this, and also it will be flowing in the opposite direction, that is like this. So that means the voltage will be changing the polarities, which is visible from this particular figure. But the voltage V in is not going to change. So therefore, we can plot the same schematic of voltage V0 for V in, which will be repeating at all time periods. So that is for the input voltage V in. Next is thyristor voltage VT1 and VT2. T1 and T2 are conducting from which instances? From this instant it starts conducting. It will be coming over here. From 0 to T by 2, the thyristor T1 and T2 are conducting, and therefore the voltage across the device is 0. And I am commutating the thyristor T1 and T2 at the instant of T by 2. So therefore, this voltage of minus V1 will be appearing across the thyristor T1 and T2 at T by 2. And after that, this voltage will be appearing across the device when in the off state. So this will be V plus minus V12 plus V1 will be appearing across the thyristor T1 and T2 during the period from T by 2 to T. And after that, again I am turning on the thyristor T1 and T2, so the voltage across the device becomes 0. And this is how the various instances of waveforms are being explained in the case of a current source inverter with a resistive load. Thank you.